Hello and welcome back to AWS On Air. If you're just tuning in or you're joining us for the first time, this is the show where we get to talk about all things AWS, and specifically, because we're here at reInvent, we're going to be talking about some of the latest and greatest launches that have happened this week. And I'm joined by my co-host.
Yes, my name is Brian Terry, and I'm a Senior Solution Architect working on the Partner Integration team.
And we have two guests here. Why don't you all introduce yourselves and tell us what team you're from?
Sure. I'm Chris Anderson. I'm a Principal Product Manager for DynamoDB.
My name is Arjun Nambiar. I am a Senior Product Manager on the OpenSearch team.
All right, so I'm getting some hints here. Okay, somebody from DynamoDB, somebody from OpenSearch.
Some peanut butter jelly.
Yeah. Two great services that I have used, recently in a reference architecture, and I was gluing together a chat application where folks could send chat messages, and the message was stored in DynamoDB, and somebody asked, okay, can we add OpenSearch to this architecture? And so I had to create like an integration between the two. So tell us, what are y'all launching?
Yeah. So classic use case, right? As you said,
Yeah.
there is like application that needs like millisecond latency, fast reads, fast writes. DynamoDB is perfect for that.
Mm-hmm.
But on top of that, now you need to build search, and search could like range from like multiple things, right? You could have basic text search, which is what you want. You could take it a notch further and like add things like geospatial search, right? You search for food, you search for cabs in a certain radius. You could do auto completions. You could do fuzzy search. And if you need to build all that additional functionality on top of that, you need to then leverage a service that's purpose-built for that. And OpenSearch is that. And so traditionally, we've seen like users, as you said, cobble up that together, right? Write some ad hoc code where they need to sort of write a pipeline that replicates the data from Dynamo to OpenSearch. This particular launch that we announced, Adam announced today morning, ensures that it's a zero-ETL integration. You need not worry about the plumbing. You just set up the integration, the zero-ETL integration between OpenSearch and DynamoDB, and the data is then seamlessly replicated between both the systems.
Very cool. So why has AWS chosen to invest in this zero-ETL integration?
And let me ask also first, what does ETL stand for, too?
Good
because
question.
some folks may not be familiar with that term.
Yeah.
You want to take that, Chris?
Yeah, sure. So this is a quiz for me, I'm guessing. So extract, transform, load is at least the definition that I've been using. And in some ways, I think the word's a little bit kind of like serverless. There's still ETL happening, obviously, but it's our ETL. It's not your ETL. Like that's kind of the mindset that I've got for that. So what this is about being able to let you do is you're able to kind of get the outcomes of ETL, but you don't have to own the ETL infrastructure yourself. That's all being done kind of for you in a no-code, like fully managed solution.
Awesome. That's very cool. I mean, in my past, I've had to do this kind of thing, like search through a wide variety of data using ETL, right? And so having something like this, I think it's a huge benefit to just most customers in general, right?
Yeah, it lets you focus on like building out applications, not having to build pipelines. Like that's exactly what we want to like enable.
Well,
Awesome.
and the other thing that I've experienced before with DynamoDB, I love using DynamoDB for storing data, but it's a little bit more of like a key value store, right? And so you technically can add local indexes and global indexes, but it becomes a little bit challenging to search across just any dimension that you want. And so that's where I can see like the melding of these two persistence and query experiences coming together to allow me to build applications the way I want to without having to really think about indexes and DynamoDB table design and stuff like that as much.
Yeah. And so,
You'll still probably want to think about DynamoDB table design. Don't catch me on that one. But certainly for those use cases where you are trying to do approximate searches, things like that, where it's not like an exact filter.
Yeah.
Like that's always going to be OpenSearch's like bread and butter.
Yeah.
And then like there's definitely this room of gray where like if you just needed to do geospatial search, would I go and use OpenSearch just for that? It really depends. Like I can do geospatial, but I got to build it myself with DynamoDB. With OpenSearch is out of the box. But if I'm just doing like filters, am I using the full power of OpenSearch? Maybe not. But as soon as I'm doing like approximate searches, things like that, absolutely OpenSearch is going to be the king.
I was thinking specifically about geospatial. I was like, I've built the geospatial index before, and it was challenging. That was something where I would totally like offload that onto OpenSearch.
Exactly. Yeah. I mean, the foundation of OpenSearch is an inverted index, right? So you will not get that kind of performance with any native SQL or NoSQL DB. OpenSearch is purpose-built for such things, and so it's always logical to offload these workloads onto OpenSearch and ensure that your core read writes are meant for your primary data stores.
Awesome. Very cool. So, can you talk a little bit about like what are the top 3 search use cases for this kind of
Yeah.
integration?
Yeah. So I think the primary, the bread and butter, as Chris said, is text search, right?
Okay.
Which is what you have chat applications, you have, say, a normal application where there is like transactions happening day in and day out, but you also want to integrate search with experience. And search has now become like, it's a given with any application, right? People want to search for chats or for certain things that have happened on the app, go back in history, pull up transactions, you need search. So full text search is one thing that's quite common. Then other flavors of enhanced search, geospatial search, fuzzy search, auto-completion, right?
Oh yeah, autocomplete.
Yeah.
Everybody expects autocomplete now.
Auto-complete, yeah.
Nice.
Especially now that Google does it for you, people expect that in normal native applications, auto-complete to be there. So OpenSearch can power that. And now with all this Gen AI craze, the last 1 year has been like advent of like just an explosion of like Gen AI and AI-powered things. We are seeing a lot of something what we call semantic search. So traditionally in search, when you see, it's a keyword search, right? So for example, when you search for something like Wild West, and if you have multiple documents which have the text Wild and West indexed, it would pull up all these documents, right? So you would probably have wild animals, you have something about West geographically, right? But when you say Wild West, what you're expecting is like cowboys or horses and all those things, right? That you associate with the Wild West. Now with semantic search, you can store all these as vectors in OpenSearch, and these are like multi-dimensional vectors, right? And so now when you store that and you create what are called vector embeddings and you store that in OpenSearch, and OpenSearch is a vector database. Now when you search, when you store that on DynamoDB and you search, for example, you have indexed documents with Wild West, and you have like documents which say cowboy, and when you search that OpenSearch, semantically, rather than looking at the keyword, we pull up the actual meaning. So rather than just like very superficially pulling up keywords, now we can actually estimate the intent of the searcher more accurately. So I think these are the 3 major use cases that we've seen. And I think the vector search is something that we're very super excited about, because with all the craze with Gen AI and AI-powered workloads, we see a lot of people trying this out.
That's actually amazing, because I remember back when search, like the state of the art was just like stemming and stuff like that, and now you're telling me that with OpenSearch, I'm going to be able to search for semantically similar things. Like I search for Wild West, and it brings up like saloon and cowboy-related results. That's
what's really great is that OpenSearch not only gives you kind of that vector search capability, but you can combine these different search methods. So you can combine kind of your classic full text search with neural search and give a combination of ranked results, do your own kind of scoring. So you can kind of finely tune the results to use a combination of like the neural search and kind of your more classical full text search. And that's really, really powerful. It's hard to get that with other solutions.
Yeah.
Oh man, super exciting stuff, man. I love it. This is awesome. So are we going to see a demo of this?
Yeah, we can show you exactly what we kind of did today. You know, to be honest, it's not all that flashy, because it's meant to be simple, right? We're gonna point and click a lot. We're gonna kind of walk through exactly just how simple it is to use this. So go through there and kind of walk through what we've got today.
Super cool.
So if you go to the DynamoDB console today, you're going to see a new menu that you didn't used to see before. It's called the Integrations tab. So we now have a tab that is dedicated for integrations. You can choose your table. OpenSearch service is the one that's GA. I don't have my account here whitelisted for the approved listed for the Redshift integration that was announced, but you can kind of see here I've got the OpenSearch integration. If I click on a table that I've not done anything to, you'll actually see this pop up that's telling you that there's some dependencies you need to enable. You can click on this, and almost instantaneously you've got all those dependencies set up for you automatically, so you don't have to worry about like reading too many docs as far as like the dependency setup goes. And when you click on Create, we're going to go ahead and open up the pipeline create workflow. We're going to actually, if you take a look at the config here, we've already automatically chosen the DynamoDB template here for you that we've got for the blueprint, and we've actually injected the ARN of the table that I just had there. So it's, again, way less copy-paste. We're trying to make it as few kind of steps as possible to kind of get started. It does take a couple minutes to go through there and create the pipeline, so I've got one through the Magic TV pre-baked for us. So once that's there, we've got a pipeline. It's created for you. The pipeline configuration YAML, rather than kind of viewing that inside of the browser, we can kind of take a quick look at kind of a more end-to-end demo of what I've got going on here. So let's say I've got a DynamoDB table. I'm using some fanciest aggregate single table design type concept. So here I've got a store. I've actually got kind of data separated out as my sort keys here, and I've kind of got my store name, Chris's food hut in this particular case. And I want to go through there and be able to do a search on store name. Today with DynamoDB, as we've talked about, I would need to do an exact search on that store name. Otherwise, I'm not going to be able to find the results. I can do some stuff with GSIs where I kind of do like starts with, and I could look for like Chris, but I wouldn't be able to go through there and like search for food hut and find Chris's food hut, right? So for that, that's a perfect case for full text search. That's where we want to use OpenSearch. So what I've got in the pipeline here is I've set up DynamoDB as we kind of saw before. I've got my table ARN. We're setting up some stream configuration, some export configuration. Again, how you kind of build this yourself, that's fundamentally how we built it here for you as well. So a lot of folks use streams, they use exports to get the initial snapshot. That's exactly how it's working under the covers here. Just some initial kind of like security setup, things like that. What's nice about OpenSearch pipelines is that it comes with codeless processors. So it's not like I've got to go through there and do a direct one-to-one replication of my data. I don't want everything that's in my DynamoDB table inside of OpenSearch. That's inefficient.
Yeah.
And so I can go through here and I can do some renaming of my keys because I don't like the schema that I was using inside of DynamoDB. I can actually create composite attributes. So in this case, I want to create a geospatial location string. And so I'm going through there and creating a new location string that's combining store lat and store long into a single field. And then with the OpenSearch configuration itself, anyone who's used pipelines before, there's not much different here, but we've added a couple of things specifically for DynamoDB to make things easy. So we've got document ID here, and we will automatically generate the document ID from the primary key if you use the default. You can customize this however you want, but by default, you can go through there and use these kind of simple things. Action maps to the actual update you saw on the stream. So if you do a delete, we'll delete it from the index as well. If you want to never delete from your index, for example, you could go through there and always make this index. And so that way you would actually keep a full history of all of your changes inside of OpenSearch, even if you deleted it from Dynamo. So you have a lot of control here, even though we've made it fully managed for you. In this case, I only wanted to index a couple of things from that table, like I was saying. So I've only got name, description, and location. And then one other thing you might have noticed is I've got these routes here. These routes are actually filters. So what's going to happen is for every single event that comes through the pipeline, it's going to apply this filter and match the item to a route using that filter. So in this case, I was looking for my sort key being equal to metadata because that's what I was using my schema. I've got my store ratings, my store menus. I'm sending these to another route. I mapped this sync to this route here. The other routes, since they're not going anywhere, they're effectively being dev nulled. So those items are going to just be dropped until I add a sync or I add that I add those routes to an existing sync. So with all of that, once you get that started, the pipeline is created and everything is kind of running. We can go ahead and see that the data that I've got here in DynamoDB, just like I've got in my schema there, if I go through there and just kind of like hit my my scan table, so you can kind of see, I've got my results of just those 3 items. So I've got my metadata item and 2 items that we don't want to do any searches on whatsoever.
I think the thing that I like so far, based on what I'm seeing here, is that I didn't have to think about how it was going to run. Like I've seen a lot of people who are running ETL jobs, and they're like, should I load everything into memory first, and then, and I tell them, you want to stream that data. You want the records to stream in, and then stream up to your other store. And because this is essentially, it feels like a serverless product. There's no code there.
Yeah.
This is just metadata describing what I want the transforms to be. I didn't have to think through all the difficult part of how do I optimize this and deal with memory and back pressure and
we're doing things like we're setting the version properly, so that way when the streams go through there and they replay over an export, the stream should always win because the stream's always fresher than the export. So like we're doing all those kind of, call it, hard consistency problems for you out of the box. So like all those weird edge case bugs you'd eventually find when you built your own pipeline, we've ideally caught all those bugs ourselves, and it's going to go through there and work for you without you having to actually like babysit the consistency and correctness of your index.
And there's a fine balance between like flexibility and ease of use, right? And so we pre-populate all this for you. These seem like multiple lines of code, but as a user, it's just a click of a button. But if you want to then play around, add a few things, as Chris said, add a few processors, change your filters, you can do all that.
Like one example there is that you don't have to include the stream or the export setting here. So let's say that I wanted to do an export because I was going to go through there and generate a bunch of vector indexes. And like I always want like separate vector indexes because my training might go differently, and I want to be able to like A/B swap between those models. I can just do the export for every single time I want to go build a new model. and I don't need to go through there and use stream to update changes because I don't want my results to start changing. So you can just use export there. And then similarly, if I've got an existing index that I've already loaded data into, but I want to change some things, I can get rid of the export and just do streams, and I'll only index new items as well. So again, it all just works for you out of the box, kind of end-to-end if you just use the defaults, but we're trying to make sure that you still have control so that there isn't any scenarios where you've got to fall back to writing code again, because that's obviously disappointing.
Awesome.
That's amazing.
Yeah.
I really like what I'm seeing here. And so, can we test it out? Can we see the search in action?
The magic here again. Nothing super fancy. You're gonna go ahead and hit run, and voila, we actually see that Chris's Food Shack item in there automatically. And we're able to go through there and do fancier. I'm not a big OpenSearch query person, so I'm not going to be writing some fresh REST APIs in front of you all right here. But as you can imagine, you could do whatever kind of tweaks you'd want on side of that data. And it's really quick to iterate on. So whatever you would want to go through there and do, if you wanted to make the index ahead of time and then have the pipeline right to the existing index, that's fine. In this case, if the index doesn't exist, we upsert the index based off the configuration. So all that stuff just hopefully ends up being fairly smooth for everyone.
Yeah. So that's actually a super interesting question. So if I modify something in that configuration and, for example, add a new entry, in that configuration, the YAML where it was like add entry, what happens there? Does it reprocess from the beginning? Or does it apply to the stream going forward?
So when you just do an update, it is going to only apply to going forward. But if you restart your pipeline, which is effectively like the update is kind of a soft restart, and like a stop start is a hard restart. That's going to go through there and trigger a full export, and then start replaying from the stream again. So you've got both options. If you want to go through there and do something lightweight, you can do that. Or you can do the hard full reset.
And is the hard full reset, is that a zero downtime thing, or is it going to wipe out the index entirely?
It does not wipe out the index. If you have a mapping template change where you would need to go through there and do like a reindexing operation, what you would probably want to do is like change the index name that it's going to go rebuild to, so that way you can still make your application, if it's using the old index, can keep on using the old index, and then you need to swap your application to talk to the new index. Like the same kind of things that happen with like reindexing inside of OpenSearch by itself. Those same patterns work when you're kind of doing the integration between DynamoDB and OpenSearch.
Yeah.
Wow.
There's a downtime for the pipeline to come up when you like stop and start a pipeline, but that's like a few minutes. Pipeline comes up, but nothing's deleted on the index.
That makes
that's
sense.
all kept right there.
And the pipeline itself, when you're doing that update, it's always doing a blue-green deployment. So it's like not going down and then updating. It's like going and doing like a nice, gentle turn off, making sure it's checkpointing everything, and then it's able to come back up and start exactly where it left off.
So you can do this in like live production.
That's super important too when you say where it comes back up right where it left off, because traditionally, if I was writing like ETL code, there's a good chance that I'm gonna miss something in the middle during my deployment.
Yeah, I mean, like that data correctness issue, right? Of like making sure that you process every single item on the stream, and that the newest item always wins. Like those are two very hard problems when you're building these kind of real-time streaming ETL pipelines. And I think that's probably the nicest part of this feature overall, is that you don't have to worry about those consistency problems. They're tough things. You learn them through lots of pain usually. So
yeah, you don't want to learn that in production.
Yeah.
You don't want to learn that on the fly when you're just trying to build business features. And so what I'm seeing here is this is going to enable folks to build their business and build their product features without spending a bunch of time trying to figure out difficult infrastructure related puzzles.
Yeah. Don't need to go whip out your distributed systems book just for this.
So I guess another question I would like to bring up, what kind of effect does this have on your DynamoDB like scaling? Like your read write, do you have to scale up, or do you have to watch that? Or what's going on there?
So you can use this on an on-demand table, and you'll see no throughput on that table. So you'll just kind of see your normal storage costs. What this is using under the covers is it's using export, which doesn't use any actual throughput to do the export. The export's built off of your pitter logs. And so that way it doesn't actually have any impact on your production data.
By pitter, you're referring to point-in-time recovery.
Point-in-time recovery, yeah. So that's a change log effectively, and so we're compiling that export based off of that change log. And then streams also uses a completely separate set of infrastructure for sending those logs via the streams API. So you're not ever actually having to interact with your read or write kind of like data plane API calls.
Awesome.
That's beautiful.
Yeah, it is.
And it's also really cost-effective to do that too. So that's another big advantage of this, is that it's a very cost-effective way of doing ETL.
I love that. We're about to run out of time, so any last comments on where folks can go to find out more information about this and get started?
Yeah, so we've got documentation both, given that it's an integration between both these services. The docs on the DynamoDB side, the OpenSearch side. So we've ensured that we don't duplicate any docs. So the relevant portion is on the DynamoDB side, it's on the integrations page. We have DynamoDB as a source on the OpenSearch side. So all of them is there. We have blueprints in the console. So if you want to get started, click of a button. All the code is already there, and you can get started, hit the ground running right away.
Awesome. Can't wait to see what people build with this.
Yeah.
Absolutely. I'm excited for it too.
Thanks so much for joining us and telling me about it today.
Thanks a bunch.
Thanks.